Here, if we do Pythagorean theorem to find the missing pieces, on the first one, you would use 4 squared plus b squared equals 8 squared. And if you solve that, you should get 4 for a, which we had already. For b, when we solve that, we should get 4 root 3. And for c, we get 8, which was given to us. On the second one, we're solving for a, and so we should have a squared plus b squared, which is 6 root 3 squared, equals 12 squared. And if you solve this, you should get 6 for a, and they had already given us 6 root 3 and 12 for c. On the third one here, we have 5 for a, so 5 squared, and then b squared, which is 5 root 3, and then c squared, and so we solve for c. We should get 10 for c when we're solving that. So we have 5 root 3, and 10. And from this emerges the pattern that we have for when we have a 30, 60, 90 triangle. Notice that each of these triangles that was given to us had a 30 degree in the bottom and a 90 degree there, and that leaves us with only 60 degrees for the other angle. So this is called a 30, 60, 90, and it's our second special right triangle. We only have 2 types of special right triangles. There's the 45, 45, 90, and the 30, 60, 90. And we already talked about the 45, 45, 90 pattern, but today we're going to talk about the 30, 60, 90. So with the 30, 60, 90, the short leg, which is the one across from the 30, is going to be like your x. The longer leg, which is across from the 60, is always the same number with a root 3 on it. Notice how the a and the b, and the a and the b, and the a and the b here, they all have the same number, but the b has a root 3 next to that same number. And then how the c's are related is that they are always double of the short leg. So if you double the 4, you get 8, double the 6, 12, double the 5, 10. So you can use these 2 rules here to get pretty much all of your answers. If you are looking for the long leg, you would take the short leg and you would multiply it by root 3. If you're looking for the hypotenuse, you're going to double the short leg. Now, if you start with the longer leg, you're going to have to divide by root 3. Divided by root 3 is going to give you the short leg. And if you have the hypotenuse, you're going to divide by 2 to get the short leg. So you can use these patterns to get the answers, or you can use the table method that I like to use. A friend of mine, she calls it the tic-tac-toe method. So the tic-tac-toe or the table method is to write the rule, which I do every time I'm doing these problems, and the rule for the 30, 60, 90 is x root 3, 2x. She calls it the tic-tac-toe because it does kind of resemble a tic-tac-toe board if you draw in these lines here. So you look at the problem you're given and you see what they have given to you. You see what angle it is across from. So right here, 5 root 3 is across from the 30. So I'm going to start by putting 5 root 3 under the 30. This means that my x value in the pattern is 5 root 3. So to get the part for the 60, I need to put 5 root 3 where the x is at and multiply it by root 3. Well, root 3 times root 3 is root 9. So I'm looking at 5 times root 9, and root 9 is 3. So we are seeing that we're going to get 15 there for the 60. Then to get the 90, you go back to the 30, which is 5 root 3, and you're going to plug that in where the x is at. So you're just doubling it. 5 root 3 times 2. 2 times 5 is 10, so it's going to be 10 root 3. And I know 10 root 3 doesn't necessarily look like it's more than 15, and it is the hypotenuse, and it has to be the longest. And so 10 root 3, if you wanted to type in the calculator, you'd get 17.3 something something. So it is the longest measurement, even though it doesn't quite look like it here. So once you've done the table and the pattern and everything, you have all the parts of the answer that you want, but you need to put them onto the picture so that you know which one is which for the variables they've given us. So across from the 60 is where you're going to write underneath the 60 is a 15. You're going to write 15 there. And across from the 90 is where you're going to put the 10 root 3. And so for this problem, x is 10 root 3 and y is 15. Again, notice the x from the image and the x in the rule are not the same. In the rule here, x is just used, as our basic variable that we like to use so often. And again, the letters in the image are not related to the letter in the rule. So on to the next one here. They have given us an 8, which is across from the 90. So I'm going to set up my rule, my 30, 60, 90, and x root 3, 2x, and they gave us the 8, which is across from the 90, so I'm going to put it under the 90. So this means that 8 equals 2x, because that's what it's underneath in the rule, and we want to solve for x first. So we're going to divide by 2, and we get 4. For this pattern, everything's related to x, so no matter which column you start with in the pattern, you're going to set that number equal to the expression for that column, and you're going to solve for x. So 4 is x, and that means that the 30 is a 4. And now you're able to plug this in for the x under the 60. So you're going to have 4 root 3 for that one. Now we're going to put these all back onto the picture. Across from the 30 is where the 4 will go, and across from the 60 is where the 4 root 3 will go. And now you have your variables that you were looking for. On number 9, we have been given an 18 across from the 60. When you're given a whole number for the 60, which is the one with the root in it, that's going to be the hardest one to work with. We are going to have to rationalize our denominator for this one. So we have x root 3, and 2x. And so the 18 is the 60, so we put that under the 60 there. And this means that 18 equals x root 3. And so we're going to divide by root 3 to get x alone. And we're going to rationalize it. Now, after you've rationalized a lot of times, you're going to see a pattern of it. Here we're going to rationalize with root 3 over root 3 because, again, that's equal to 1, and we're using a 3 because it's a 3 here, and that's going to pair them up so that they're able to get out of the root. So the numerator is 18 root 3, and the bottom is root 9, and we know that root 9 is 3, so we're really looking at 18 root 3 over 3. And in this case, 18 does divide by 3, but if it did not, this would be the answer for what x is. But 18 divided by 3 is 6, so the answer is 6 root 3 for x. So in my table, now I know that x is 6 root 3. Now that I know x, I can find what 2x is by just taking that 6 root 3 and doubling it, which is going to give you 12 root 3. So my 30, as we see in the table, is 6 root 3. And my 60 we already had, and across from my 90, which is where the y is at, is going to be 12 root 3. And then we have our two answers there. So when you're dividing by a root 3, you will always end up dividing by 3 and multiplying the top by a root 3. And when we were doing this with the 45, 45, 90 earlier, we ended up dividing by a 2 and putting a root 2 on it, which, let me find that, it's down here at the bottom, right here. So we had ended up, when we rationalized it, we had division by 2 and a root 2 on the top there. And so when you're rationalizing and dividing by a root 2, just divide by 2, put a root 2 on it. And when you are using a root 3 for the 30, 60, 90, you divide by 3 and put a root 3 on it. So let's look at a couple more here. So number 12 is one that is really nice, although when you look at it at first, it doesn't look like it's going to be a good one. This is across from where we would have a 60, and so the rule of 30, 60, 90, which is x root 3, and 2x, has a 60 as 13 root 3. So that means that 13 root 3 equals x root 3. And when we divide by 3 to solve for x, we're just going to cancel the root 3's, and x is 13. And so that means that the 30 is 13, and then you can double that to get the 2x, so we get 26. So it's like if I start with a 60, I go to the 30, and then I take the 30 and I get to the 90. These are your basic problems. Sometimes you have a problem that's a little bit different like this, and often they don't have this line drawn in and you have to draw it yourself. So sometimes they give you a trapezoid and you want to break the trapezoid into, in this case it's a square, but sometimes it's a rectangle and a triangle. And they've given us some measurements over here, and I knew it was a square because they've got 3 right angles here for us, and that means that this is automatically going to be a right angle because a quadrilateral adds to 360, and the 2 sides are the same. So, and no matter what, even if it was a rectangle, the opposite sides of a rectangle are equal, so you can use these labels to get over here onto the triangle. We can see in the triangle that we have a 60-degree angle label, which makes this a 30. And they sometimes also do these with 45, 45, 90s. So what we have to start is we have a 6 across from the 60. So I have my rule, my 30, 60, 90, which is x root 3, and 2x. And so across from the 60 is a 6, and that means that 6 equals x root 3. So we're going to divide by root 3 on both sides and rationalize. And so we get 6 root 3 over 3, and that does reduce to 2 root 3. So this means my 30 is 2 root 3. And to get the 90, you just double the 2 root 3, giving you 4 root 3. Then we're going to label that back onto the picture. So my 30, across from it is the letter B here, and that is going to be 2 root 3. And across from the 90 is where the A is at, and that is going to be 4 root 3. So now I have A and B, but there are often times where we've also requested for people to find like the length from that spot to this spot, and so to do that you'd have to be adding the 2 root 3 and the 6 together. And so just to address that real quick, and we've seen where we've had to do this before in like unit 1 we talked about it, you are not able to add a root with a whole number. You can multiply them, but you can't add them. So you would just write this as 6 plus 2 root 3 to be like, say that was variable C or something.